All right, so here is our first problem in section 6.2. And for this first part, you're going to notice that we are just simplifying some expressions that have exponents in them. But one thing that should strike out at you right away is this little letter E that we're using in here as our base. Now, normally for variables we use numbers like X or Y or Z, but this is a little different here. E, we actually have the definition of it in our journal, so I'm going to skip to that for just a second. E is defined as the natural base, and E is not a variable at all. E is actually an irrational number that is roughly equal to 2.718. Now, we're going to do a little exercise in class, in next class, that shows how we find the value of it, but the rough definition right here is it's defined as the exponent, the value of 1 plus 1 over x to the x power as x approaches infinity. So if you take 1 plus 1 over a really large number and take that to that really large number's power, you're going to get roughly 2.718281828, so forth. So if you keep, as your number gets higher and higher and higher, you're going to keep extending this decimal out and out and out. Now, if you think of another irrational number that we use a lot but we don't have an exact value for, I hope that the number pi comes to mind. So pi, which is this symbol right here, is roughly equal to 3.141592, and so forth. So pi is an irrational number and E is an irrational number. So think of them as just, very similar. They both have decimals that never end. They both are represented by these symbols instead of the actual decimals, and we use them both in math a lot. Now, E is used for things like compound interest, and you also see it a lot in calculus and higher level math, and you also see it in nature when you talk about some ratios of things like the golden number and the ratio of spirals and cones and things like that. So just that's a little bit of a background on E. All you need to know right now is that E is an irrational number that is a never-ending decimal that is roughly equal to 2.718, and we refer to it as the natural base, E. So let's go back to our problem right here. And now that you know that E is actually just a number instead of a variable, and we don't write out that decimal, 2.718, and we don't actually calculate 2.718 to the third power times 2.718 to the sixth. We actually just leave it in terms of E. So now that you know that and you look at these problems become very simple. Calculating E cubed times E to the sixth, we just think of this as what is x cubed times x to the sixth. We're not going to plug in a value for E. So for this problem, you just treat them as we are multiplying two exponents together with the same base. So if you remember our properties for that we learned last semester, all we do is we add our exponents together. So 3 plus 6 is just 9. So we get e to the ninth power. Okay? Simple. Don't try to plug in any values for e. Just keep them the same and just use your properties of exponents. So here, if you remember, again, we're not going to be plugging in any number values for e. So all we're going to do is use our properties of exponents. And here, we see that 16 over 4 can be simplified to 4. And since we have a fraction with two bases that are the same with exponents, we just subtract 4 from 5, and we end up with 4e to the 5 minus 4, which is just 4e to the first power. Okay, again, we're just treating e like any other variable right here where we don't plug in an exact number. So here, now we have a little bit more going on. We've got 3e to the negative 4x power all to the squared. So what we're going to do first here is we're going to go ahead and we can actually take out some of the values here. So if we look at this, we can actually go ahead and distribute this 2. So this is the same thing. We distribute this 2. We find that this is the same thing as 3 squared times e to the negative 4x squared. What we're doing is we're separating our natural log portion from our constant portion. What we can do from here is now distribute this 2 into here. So now we get 9 times e to the negative 8x. 2 times negative 4x just gives us negative 8x. So all we've done, we've factored out the constant portion, the rational portion, and we've left the irrational component together. That's all we're trying to do in each of these problems, is get the irrational and rational parts separated from each other. Okay, so again, factor out whatever you can that's rational and leave whatever's irrational by itself.